Right, in this video, we are covering a very basic calorimetry problem. So let's say you're given the following. If you placed a 72.5 gram piece of metal that has been sitting out on a table with a specific heat capacity of 0.445 joules per gram degree Celsius into a cup of hot water with a mass of 38.6 grams that was at a temperature of 99.5 degrees Celsius. And if the temperature of the water dropped to 87.5 degrees Celsius, the question is, what was the initial temperature of the metal in degrees Celsius? So first things first, when you see a bunch of numbers and units, it's just good to know like what you have. List your knowns. So the metal, they gave us the mass, the specific heat capacity, the final temperature. What we need to find out is the initial temperature. Fair enough. And then the water, they gave us everything we need. The mass, the specific heat, both temperatures, and we find that the delta T, or the change in temperature, is negative 12 degrees Celsius. I forgot to put the unit there. My mistake. So then after you list out your knowns, recognize what is happening conceptually. So it stated that the water was initially at this high temperature and then it dropped to 87.5 degrees Celsius. So that means that water is losing heat. But as we know in classic thermodynamics, energy is never like destroyed or created, it's just transferred. So this means that the metal is gaining heat. So as the water is losing heat, the metal is gaining heat. So that is what is going on here. So this will tell you, like later on in this equation we're doing, why the joules are negative. So we can use the equation Q is equal to mc delta T to solve for the initial temperature of the metal. So we'll take some algebra tricks to kind of get to our desired result. But let's go ahead and given this equation, we can solve for the Q of the water, the heat content of the water, because we have all the components we need for water. Plugging it into this equation. So we have Q is equal to M, which was the mass of the water, 38.6 grams, and times that by C, the specific heat capacity, which was 4.18 joules, and times that by our delta T, or the temperature difference, which was negative 12 degrees Celsius. And as we list out our numbers with their units, we see some units canceling. The grams cancel, the Celsius cancels. We want that all that stuff to cancel because then we get the heat energy of the water in joules, which is our desired unit. So the heat lost by the water during this temperature change was measured to be negative 1,936.176 joules. Okay, now go back to this equation. So the heat of the metal that was gained is equal to the heat lost by the water, and we determined the heat lost by the water was this value. So now we know that positive 1,936.176 joules was gained by the metal. So now we can plug everything in to this equation to solve for the initial temperature. So let's back calculate. Rearrange Q is equal to mc delta T for T. So you have delta T is equal to Q over mass times the specific heat. And so we put our delta T over here for the metal, which is final minus initial. And our Q is positive 1,936.176 joules. And we divide that by our mass of the metal, which is 72.5 grams, and also by the specific heat, which is 0.447 joules. Our units cancel nicely to give us degrees Celsius. And so finally, our delta T is equal to 59.74 degrees Celsius. You just, move this number around to that side, and it's going to say negative x is equal to negative 27.8 degrees Celsius, but ultimately positive x is equal to 27.8 degrees Celsius. And so, yeah, we answered our original question, and that's it. See you in the next video.